Welcome to example number 3. We have a brass rod that is 69.5 centimeters and an aluminum rod that's 49.3 centimeters that just quite don't meet here. They don't, if you add these two numbers, you're not going to get 120 centimeters. So there's a gap between here. They're both at these lengths at 0 Celsius, and we want to know what temperature would they be needed to be heated at to a final common temperature such that when they expand, they're now going to meet in here, so the aluminum and the brass will now meet and just barely touch each other. So what I'm going to do is I'm going to separate the given into sort of two columns here. So we'll start off with the brass. We have a initial length of brass of 69.5 centimeters. We're told that the initial temperature of the brass is 0 degrees Celsius. We also know that the coefficient of linear expansion for the brass is given as 2.0 times 10 to the power of negative 5 and Kelvin to the power of negative 1. I could, by the way, write this as degrees Celsius to the power of negative 1. It would be the same because a change in Celsius is the same as a change in Kelvin. Okay, over here we have aluminum. Aluminum's original length, we'll just call it like this, is 49.3 centimeters. Its initial temperature is also 0 degrees Celsius, and its coefficient of linear expansion is given as 2.4 times 10 to the power of negative 5 and Kelvin to the power of negative 1. Now, we know that after they expand to some new temperature T, which is what we're looking for, that will be the same common temperature for both of them. That when you get the final length, this length here of the brass and this length here of the aluminum, they must add up to 120. So we know that the following condition exists. The length of the brass plus the length of the aluminum must add up to 120 centimeters. Okay, so how do we calculate the length after it's been heated up? Well, the length of the brass is the initial length of the brass plus the change in length of the brass. So this is really the length of the brass initially plus the initial length times the coefficient of linear expansion times the change in temperature, delta T. And a similar equation can exist as well for aluminum. So the initial length of the aluminum plus the initial length of aluminum times alpha times delta T. Now these two alphas are different, these coefficients of expansion. This is for brass and this is for aluminum. So let's now substitute each of these equations into here. So we're going to plug that in here and in here. And we're going to get the following. And then we can start to substitute numbers in. And then you can see that we have two like terms, and simplify this expression. And we get the following now simplified expression where I've taken these 69.5, 49.3, put it on the right side, and then combine this term and this term algebraically. And I get a change in temperature of 466 degrees Celsius. Now the change in temperature is the final temperature minus the initial temperature, but the initial temperature was 0 Celsius. So that really the final temperature is 466 degrees Celsius. And that's it for this example.